Now continue to think about this triangle that we had right here. Here's a convention that we're going to use for the rest of the unit. When an angle is called angle capital A, the side opposite is going to be called lowercase a. And so where we see the lowercase b here, we're going to call the angle opposite it angle B. And where we see the side C here, we're going to call the angle opposite it side C. So as I'm looking at the equation that we have for the area here, we could have chosen instead to write the area as 1/2, let's call this A times C, and if we had done that, then that would change the angle that goes in this position. Here's A, here's C, the angle between them is B. Well, think about it for a second. Aren't these right here the same area? Since they're both finding the area of this triangle. So technically, we could make this statement. 1/2 times A times C times the sine of B is equivalent to 1/2 times B times C times the sine of A. And I can't help but notice that on those two sides of the equation, both sides have a 1/2. So I'm going to divide that 1/2 away. And then I can't help but notice that they both have a C. So I'm going to divide that C away. And we're left with A times sine of B is equal to B times sine of A. Well, if we take both sides of that and we divide by AB, something very nifty happens. On this side over here, the b's cancel, and we get the ratio of the sine of angle A divided by the opposite side. Over here, our a's are going to cancel. And if you look at what's left over here, we get the sine of angle B divided by side B, and they're equal. Hey, and it shouldn't surprise you too much that we can go one step further and say that if you take the sine of the third angle in the triangle and you divide it by the side opposite it, all three of those are going to be equivalent. And that's what we call the law of sines.